Good. All right then. So I think we're in a position where we can move on to some slightly more interesting things with logarithms. Like I say, I haven't really gone into the reason why we look at logarithms. That's kind of done in the asynchronous hour, like the reason why we look at logarithms. But what we're going to move on to now are something called laws of logarithms. Now, you remember when you met exponentials, you met these kind of power laws. You met these laws of indices. Okay, things like, for example, if I have some base, let's say b, raise it to the power of n, and I times it by the same base to the power of m, what should I do with those two powers? Yeah, so it should be b to the power of n plus m. And then we might have something like b to the power of n divided by b to the power of m. What should I do with those two powers? Yeah, good. So we looked at very, very similar questions to this in the first hour. Sorry, not the first hour, the first bit of the lesson. Just one more. Let's say, for example, b to the power of n all raised to the power of m. How could I write that? Yeah, multiply the two powers together, right? Like so. Yeah. So these are just laws of indices. Now, I actually hate the word laws because then that kind of implies that you have to follow them. Okay. In other words, it's like, well, you have to follow them because a law you have to follow, otherwise something bad will happen, right? Whereas that's not the case with laws of indices at all. The whole point of laws of indices, really what I mean there is they are just shortcuts. They're ways of making things easier to deal with. Okay, so I just want you to think, when I say laws of indices, what I really mean there is a shortcut. Because of course you can absolutely work this out as a kind of manually. You just realize that's repeated multiplication, that's repeated multiplication, and you're doing more multiplication, so therefore you just end up with that many more things. And the same thing with divide, you get those cancellations, and this just basically repeated multiplication within repeated multiplication. So I don't want you to kind of get hung up on the word law, because a law is a kind of a scary word. It means you have to follow it, and that's not the case with these. Okay, so we've got laws of indices. They're like exponentials, exponents, right? It makes sense that because exponents and logarithms are related, they're literally the same thing, just looked at from different perspectives. It makes sense then to have these things called laws of logarithms as well. Now again, don't think of them as laws. Think of them as a shortcut, okay? But they all stem from these things called laws of indices, okay? So I'm actually going to work it out down here. If I write this down, so if I have, for example, log of x, okay? What's the power in this? Sorry, no, what's the base in this case? It's not 0. It's not 0. You notice I haven't written it. Like usually when I write a logarithm down, like log to the base 2 of 8, okay, there's a base there. There's a base going on. I haven't written a base there. Now, I don't want you to worry about this too much, okay? But the idea is if I don't write a base there, I've automatically implied a base, okay? Because it can get quite cumbersome to keep writing bases in. It can kind of get quite awkward with notation, and particularly if you're trying to type this in a computer, it takes a long time to type a base in every single time. So if I just write log down, I just want you to think, I don't care what this base is. So it doesn't matter what the base is, but they have to be consistent, okay? So if I don't write that in there, it doesn't matter what the base is in that case, okay? In actual fact, it means a couple of things. It can mean log to the base e of x, or it can mean log to the base 10 of x. So if you look on your calculator, there should be a logarithm button. It's usually in the top right-hand corner. Have you got it? Yeah, and you see there's just log there as well. Now on your calculator, it means log to the base 10. That's because it's a scientific calculator. A mathematician would use log to the base e, but it doesn't really matter. Okay, so don't worry about that too much. Effectively, all I want you to take away is that if I have log of x written down, it means I don't care what the base is. I just mean the base is consistent regardless of what it is. Okay. So that's the first thing. So I'm actually going to put a base in just for the sake of consistency. So let's say I've got log to the base 2 of a. And later on I'll get rid of those base 2s, then just show it's true for every single base. Okay. Now what happens if I add another logarithm, same base, but it's perhaps different things. That's A and that's B, okay? I want a way of combining these together, okay? Well, what I'm actually going to do is I'm going to let this thing equal x and this thing equal y, which means effectively I've just got x plus y. So let me write it out over here on the left-hand side. So I'm saying x is equal to log to the base 2 of a, and y is log to the base 2 of b. Now, can I ask you to look at these two things, so x equals log to the base 2 of a, y equals log to the base 2 of b. Can I ask you to convert this into exponent format? Okay, so just like we were doing a second ago, could I ask you to convert these two things into some base to some power equals some number? Okay, so this one here, the x equals log to the base 2 of a, you write it as exponent format, what do you get?
2 to the power x equals a.
Perfect. And this one?
2 to the power y equals b.
Perfect. Okay, so I'm just going to use that, right? Now look, I'm adding up here. Just remember, a logarithm is really looking from the perspective of my powers. Okay, it's really looking from the perspective of my powers. So can you think of a logarithm law, an indice law, written them up here, where you add in the powers? So which one? 1, 2, 3. Which one do I add in the powers? Yeah, the first one. I'm adding in the powers up here, right? So I'm literally just going to apply the same kind of principle there. So I know that because I'm dealing with these two logarithms here, I know that if I multiply these two things together, okay, so if I do 2 to the power of x times by 2 to the power of y, that should be the same as 2 to the power of x plus y. Happy with that? And are you happy that 2 to the power of x is just a? And again, 2 to the power of y is just b. So really what I've got on the left-hand side is a times b equals 2 to the power of x plus y. So just by noticing the fact that I'm just adding two logarithms are talking in terms of the powers, realizing that I know a law of indices rather, where I add in the powers, write it down, and I'm able to get to there. Now, just think, if I was going to convert this back into logarithm format, let's do it together. The power, in other words, the x plus y, would be log, what's my base? It's the 2, right? And my number in this case is just a times b. Is that okay? So have a look, this is exactly what I wanted. I have shown you that just by realizing that I'm adding the powers together, okay, I've realized using a law of indices that I'm aware of, that in other words, if I have x plus y, which is what I've got here effectively, that should be the same as log to the base 2 of ab. So in other words, this thing here should be log to the base 2 of a times b. Does that make sense how I've got there? Yeah? So I can now rub all of this off if I wanted to. So I can get rid of all that. This is my first law of logs rather. Okay? Now I said to you that actually it doesn't matter what that base is. Okay? It can be any base you like. So I'll just get rid of the base just to show it can be any base you like. So my first law of logs is basically saying if I have log of a, so log of some number, plus log of another number, now they could be the same number I guess, so log of a plus log of b, that should be equal to the log of the two numbers being multiplied together. Okay, so log of a times b. Now have a think, are you happy that that is kind of analogous to your first law of indices, yeah? Times in the bases, add in the powers. Logarithm is just really looking at the perspective of the powers, so I'm adding in the powers and I'm timesing in the bases down there. Yeah, some timesing in there. Does that make sense? Yep. All right, fine. So let's do the same thing, but let's this time swap out the add for a subtract. Okay. Now I've got a similar kind of thing to before. That there is just x. Happy? I should write the log to the base 2 in again, just to make sure it's clear. Okay. So that thing there is just x. And that thing there, well, that thing there is just y. So in other words, I'm subtracting x from y. Sorry, y from x. So x take away y. So can you think of a law of indices where I subtract, these things are just powers. Can you think of a laws of indices where I subtract the powers? You happy it's just that one? Yeah, the second one. Because look, I'm basically talking about logarithms, they're powers. I'm subtracting the powers with that one, which means I'm going to divide in the bases. So let's have a think. I know if I'm working with exponents, if I divide these two things by each other, so if I do 2 to the power of x divided by 2 to the power of y, then I'll end up with 2 to the power of x minus y. And that's kind of what I wanted there, the x minus y there. Okay. So therefore, I know that 2 to the power of x, well, 2 to the power of x is just a, and 2 to the power of y is just b, and that's equal to 2 to the power of x minus y. Now I guess I could write this, if you like, as a over b rather than a divided by b. So if I just wanted x minus y as the subject, I wanted that power as a subject, could you put it back into logarithm format for me? Perfect, well done. So in other words, when I subtract these two things, x minus y, which is log to the base 2 of a minus log to the base 2 of b, that should just be equal to log to the base 2 of a over b. So in actual fact, again, just as before, I can get rid of all of this. It's just what's kind of my reasoning, my proof, if you like. And of course, it doesn't matter what base I'm using as long as it's consistent. So I just chose 2 arbitrarily, but I guess I could use any base I like. So therefore, what I can say is that the second laws of logs is going to be if I take logs to some base of a, instead of adding, I'm going to subtract log to the base something of b. That should be the same as taking the same log to the base, but this time I should divide there. And are you happy that's kind of analogous to the second laws of indices? Because you're basically saying, look, a logarithm is just a power, so I'm subtracting powers. Look, subtracting powers, and I should divide in the bases. Well, look, I'm dividing in the bases with that one. Okay? So at the moment, 1 and 2 kind of seems intuitive. You happy with that? All right, let's have a go at this one. All right, let's have a go at this one. If I had some number, let's say a, in fact I can get rid of all of this now. This was just to help me with the last two. If I have some number and I times it to log of something, so again the base doesn't really matter in this case. Well, let's actually do this with a real life example. Let's do it with a specific example. Let's say 3 log of 2, okay? Now if I say 3 times something, that's literally what I've got here, 3 times something, are you happy that's just log 2 plus log 2 plus log 2. Log 2 add itself 3 times. You good with that? Yeah? Okay, well log 2 plus log 2 plus log 2, could I combine these logarithms together?
3 log 2.
Not 3, well it is 3 log 2, but could I combine it together in a different way? What am I doing with these logarithms?
Adding them.
What does the first law of logarithm tell me? If I'm adding logarithms together, multiply with the 2's. Yeah, good. This will be log,
6.
not 6, 2 times 2 times 2, 8. Good, exactly. I'm actually going to write it as 2 times 2 times 2. Yeah, just to show you. And I guess I could write 2 times 2 times 2. Shortcut would be log of 2 cubed. Happy with that? So look where I started, okay? I started up here with 3 log of 2. Now I ended down here at log of 2 cubed. What do you notice?
The 3 became a power.
Excellent. The 3 out the front becomes the power up there. Okay. So therefore, I was going to generalize this. In fact, I could probably write it up here if I wanted. If I have some number times the log to some base of b, how could I generalize this? What would that become? Think about what we did here.
Log b to power a.
Good. So in other words, the power, the a climbs up to become a power like that. Okay, so I can get rid of all this. Now this is kind of analogous to the third law of logarithm that laws of indices that I've written down, that one there. Because it's basically saying, look, remember this is talking about power, I'm kind of timesing the power by something. Well look, up here I'm timesing the power by something, okay? And that's equivalent to kind of having it as a power up there instead. Okay, so it's kind of equivalent to 3. So I'm just trying to draw some parallels with laws of indices on the left-hand side, laws of logarithms on the right-hand side. Okay, do you see that kind of comparison between the 3? Yeah.